Hello, hi, good evening, everybody. I hope my video is visible and I'm audible. If someone could confirm.
Yes, ma'am.
Okay, hi. Yeah, good evening. So welcome to today's tutorial session. Um, Maybe we can wait for 1 or 2 more minutes so that others may join, and at 7:02 we will start the session. Okay, yeah. Meanwhile, I'll just share the presentation.
Ma'am,
Yes,
my one request is there.
yes.
Ma'am, can you repeat the previous one class?
Previous one class in the sense?
हाँ मैम पिछली क्लास के थोड़े क्वेश्चन समझ में नहीं आए थे.
Okay. Are you talking about yesterday's tutorial
Yes ma'am.
session?
Yes ma'am.
Okay. So don't worry. Actually, it's only one tutorial session per week is what is planned. So today's will more or less be a repetition of yesterday. So don't worry about that. Hello?
Okay ma'am.
Yeah. So we will discuss the problems, whatever was discussed yesterday, we will discuss that. If time permits, we will discuss something more also. But yeah, definitely the problems which were discussed yesterday, we will discuss that today also. Is there anybody else who joined yesterday apart from Jairaj? Nobody. Okay, good. So the idea is that we will discuss certain questions and how to solve the assignments. So it's if you join for any one of the session in 1 week, that is adequate enough. It's not necessary that you join for both the sessions because there'll be a lot of overlap. It's two different people who are discussing. The content might be same. Okay, so I think we can start right now. So once again, welcome to today's tutorial session on urban utilities planning, planning, water supply, sanitation, and drainage. Most of you might have already gone through all the video lectures for the 4 video lectures which were already given. So this tutorial session mainly focuses on how we can solve certain assignment questions or certain questions related to what we learned. Yeah, certain questions that we can solve what based on what we learned in this entire week. So the idea is that we have a one-on-one interaction so that whatever we learned we can put it or apply it over here. So it will not be a repetition of the uh, lectures which were already there, but we will go question by question. So we'll take certain questions from previous years assignments so that you can solve this time's assignments easily. So moving ahead, just to give an introduction. Sorry, I forgot to introduce myself. So I am Jeslu. I am a Prime Minister's Research Fellow at the Architecture and Regional Planning Department in IIT Kharagpur. And every Tuesday's tutorial session I will be conducting. So whatever we discuss right now, if you have any doubts regarding what we discussed, we will have a doubt clearing session towards the end. But if you have any further doubts, you can always put it in the discussion forum also. And if you want, if it's particularly for this particular session, some doubt you have, then you can address by my name and then put it. Like you can tag me and then put it. Right. So just to give a brief introduction, so these were the different lectures that we learned in this entire week on this course. So we learned about what are the different issues in urban uh, yeah, so let me might interrupt a bit because some people are just joining, so don't mind that. Yeah, so we discussed about what are the different issues in urban planning, what are the different planning strategies, and what is urban utilities and what is sensitive urban planning. So these were the broad topics that we discussed. I hope most of you have gone through the video lectures. Even if you have not, you still have time to go through the lectures and attempt certain questions. So as discussed today, we will be solving certain questions. Like we will take each problem by problem, and we will try to look into the theory behind. If it's a theory question, we will try to look into the theory behind, and we will see how we can solve these questions. So this will be useful not only in solving your assignment questions which you have to submit every week, but also for your final exam. Certain questions like this might appear, so it will be very useful. So before we begin, I would like to set certain ground rules so that we can make this whole session more smooth, and it would be a very productive discussion. So we will go question by question, and after each question, I will leave a 2 to 5 minute window for you to ask doubts on that particular question. So it's a request that you ask doubts only on that particular question in that 2 to 5 minute window. You may unmute and ask, or you can even put it in the chat window. I will answer the question. And after that window passes, we will move on to the next question. So if you have any doubts on that particular question, like after the window is passed, you can wait till the end of the whole discussion so that we can take it up at that time. Even if you put it in the chat box, I will take it up in the end. Don't worry. So yeah, so if you have any other general doubts or anything that we discussed, last around 5 to 10 minutes, we will dedicate only for an interactive session where we will be discussing your doubts particularly. And also, yeah, so in online, we have this issue. So in case my video or audio or my presentation or anything is getting stuck, feel free to let me know about it so I can go back and resume from where it got stuck. So yeah, so we'll try to solve together. So I request all of you to have a note or a pen or pencil and a calculator, like the scientific calculator. It would be more better to have a calculator than use your phone or computer, because in normally it would be much easier to do it this way and faster. So yeah, so let's get started. If there's any doubt in whatever we discussed till now, you can shoot right now, or we will proceed on with the questions. Anybody? Right, yeah. So let's proceed on with the questions. So, first question is that which among the following causes decline in groundwater level? So, and certain options are given with certain combination of these options. So, this firstly, let's look at why decline in groundwater level is important and what causes this. So, in India, okay, there's a slight delay in my presentation. Sorry, there's a slight delay. Uh, yeah, so in India, groundwater is depleting every year, like about 10 to 25 percentage of 10 to 25 millimeter is being depleting from 2002 to 2016. And this has caused about 54% decline in India's overall groundwater level. So this is a very serious concern for us. And certain practices or certain reasons why this is happening is something which is very common, which we see always, which are around us, but we don't realize that this eventually contributes to this groundwater decline, and it makes it very difficult for us to recharge our groundwater. So some of the reasons which are listed here, let's go one by one and let's quickly see on whether this actually causes a decline in groundwater level. So the first one is uncontrolled and illegal extraction of groundwater. So what happens when there is uncontrolled or illegal extraction is that there is no check on what is happening. There is no accounting on what how much water is being used. So because of this, what happens is, so there's a recharge. If this is a groundwater table, there's a recharge A which might be coming. But since there is no check or no accounting, whatever is being taken above from it, that is B will be greater than A. So if B is greater than A, that means there's a decline which is happening, and eventually it might even lead to complete draining of groundwater. So this and when we say there is no accounting, no cost check is also there. So which means when people are not paying for it, again, there's a lot of misuse which is happening. Water is being wasted. So, and also certain group of people extracting and enjoying the benefits of it, that is also not good. So yeah, so the first option, we see that such uncontrolled and illegal extraction leads to decline in groundwater. So our option A is valid for this particular question. And second one is rapid urbanization. So now, how does urbanization relate to groundwater? So it's again related to the same principle that we have a fix. So if this is the groundwater which is there, whatever is coming in A, which is fixed. So now earlier, if there were only like a few people and if about 100 liters were being used per day per person, now when there are more people, then we require more water to be used for each persons. So when there's rapid urbanization, when the population is increasing, at the same time with new industries and new buildings and new settlements coming in, the water requirement increases. So urbanization actually increases the requirement, and this requirement is not matched with the recharge which is happening. So in this case also our B will be greater than A, and this leads to decline in groundwater level. So our B is also right. And option C is construction of concrete surfaces. Now, how does construction of concrete surfaces affect? So we know that if this is the level and if we have the surface, we know that whatever water comes onto the surface need to penetrate onto the through the ground onto the water table in order to recharge the groundwater. So when we have concrete surfaces, it's not permeable. So the water just gets remains on the surface and it's eventually evaporated, or it flows through the nearby water streams. So again, the immediate recharge does not happen. So this again leads to decrease in groundwater level. So one of the solution for that is to use certain permeable blocks. That is, instead of using complete interlock blocks, if you use permeable blocks or leave some grass openings in between, it leads to recharge of surfaces. So yes, so this also leads. And the last one, lack of enough water recharge structure. So this is straightforward. If we don't have enough recharge structures, or if we don't have enough facilities by which this water can be trapped and used to recharge the groundwater table, this also leads to reduction in groundwater level. So to answer this particular question, all the four options lead to decline in groundwater level. So going back, we have that in option D, where A, B, C, and D leads to decline in groundwater level. Any questions on this? No. So let's proceed on. So yeah, that was a very simple question. I'm pretty sure the explanation was, in fact, not required because most of you would know what that is. So now we are going on to the next question. Here we will try to solve a problem. So this again, I would request the participants to kindly solve it with me so that all doubts can be cleared then and there. And yeah, as discussed, a scientific calculator would be very useful. So in the lectures, we have learned about population projection for planning these utilities. And we've also discussed why it is important, because we are not planning the utility for a group which is existing right now, but there is always a design period for it. We are planning it for a longer duration. So within that duration, whether whatever we are planning is adequate enough for the population which would be there at that time, to look into that is very important. So that is why we project, or we look into what would be the population projection. And there are different methods by which this population projection is done. So in this particular question, the question is regarding arithmetic increase method. It's a mathematical method which is used for population projection. And the question asks you to solve or to find the number of people who would be present in a particular year in 2031. That is what is given in 2031 based on arithmetic increase method. So let's begin this. So let's start by first writing down the information which is given to us. That is, we have the year which is given, and the population. So this one, I'm just writing it, I'm just transposing it and writing it so that the calculation becomes easier. So in 1991, we have a population of 80500 people. And in 2001, we have a population of 0. So I'm just writing it this way. You may just this, I'm just repeating the same thing. Right. So this is the information that we have. And we also know the formula for the arithmetic increase method. That is, for a given year, that is T is a given year in decades that we use in decades. And the increase would be base population plus how many decades that we are using. That is the number of decades that we are. So in this case, We want to find for 2031, and we have information. The base population is given from 1991. So we'll have like 2031 and 1991. So we'll have like 4 decades. Like after 4 decades, what is going to happen is what we need to find. And we also need to find M, which is nothing but the arithmetic increase which is happening every arithmetic increase, or within a year, how much is the population increasing. So our main task here is to find what M is. And once we get that, then we can solve the whole thing. So in order to find that, let's look at what is the difference in population which is happening for each year. That is from 1991 to 2001, how much is changing? 2001 to 2011, how much is changing? So that I'm putting it as another table as increase, like another column over here, which talks about the increase. So we just need to subtract this, So you can do it parallelly, subtract it, and then tell the value that you're getting. Yeah. So if somebody can do it quickly and tell me the value, that would be good. Right. Am I right? Is everybody with me, or am I going a bit fast? Any responses? Okay. Are there responses in the chat box? No. Okay. Right. If you've all reached till here, you can just give a confirmation so that I can proceed further. It would be nice.
Yes,
Yeah, cool.
ma'am.
Thank you. Yeah, thank you. Thank you. Right. So this increase is happening over 2 decades. That is, from here we have got 1 decade, and then in this difference we have another 2 decades. So when we calculate M, I'm just going on to the next page. Yeah. So when we calculate M, we would want to take the average, what is happening, average across the 2 decades, and we have to divide it by the number of decades in which we have been, or basically you're taking the average. So you're taking the sum, you're taking the sum and you're dividing it by the number of decades. So in this case, if we just add this both up, like quickly, let's add this both up. 5, 9, yeah. So this we have to divide it by 2, and the value, yeah, can somebody quickly tell me the value? Right, so I've written the value over here.
Yes, ma'am. It's right, ma'am.
Right, cool. So I'm just copying it over here. Yeah, so this is our M value. So yeah, so now this is pretty straightforward. Oopsie. Yeah, pretty straightforward right now. So we have, for this particular year, in our case, it is 2031. So how do we go? Our base population from the previous one, we know that it is 80500 plus, and we are now taking 4 decades. It is 2031 is what we want. So 4 decades, and we are plugging in this value over here. Yeah, so I would request to give me the answer for these.
Ma'am, your screen froze.
Is it?
I guess network issues.
Is it? Okay. What are you seeing right now? Hello. Okay, let me just. Okay, right. Are you seeing the page where I've written T 2031? Are you seeing that page? Or is it some other slide?
Now it's blank, ma'am.
Is it
Now
so?
it has come again, yeah. I guess it's my network issues.
Right. Okay. Slide number 7 can be seen. Yeah, yes, I am in slide number 7. Thank you. Right, so the final answer for this, and if we go back to our options, I'm just going back to our options. Yeah, so do you see the number over here in the option? It's option B.
Option B, ma'am.
Yeah, right. So so now if you have any doubts in this, you can ask for this arithmetic increase method. Any doubts? No doubts? Yes. Okay, let's proceed further. So now we're in question 3, slide number 9. So this one, it's again a population projection question where you need to use the incremental increase method. So in theory, we have already learned that the difference between arithmetic increase method and incremental increase is that arithmetic increase does not consider the increase which is happening every year. Like it takes the increase which is happening every year and eventually averages it out. So if from A to B, that was from like 2001 to 2010, in A to B, if there's 100 people are increasing, and from B to C, if there's only 50 people who are increasing in 2000, yeah, if there's only 21, if only 50 people are increasing, in arithmetic increase method, this would be averaged together and say that every year 75 people are increasing. But sometimes we would want to know, but this pattern might be, we would want to capture this pattern also. That is, there's an increase and now that increase is reduced. So the change which is happening in the increase also, that also we need to capture. So that is the reason why we use incremental increase method, and compared to other geometric methods, this has a bit more edge because it gives us a more accurate result, or the assumptions that we're using in this is lesser compared to our arithmetic increase method or geometrical increase method. So yeah, so similarly, like just how we did the arithmetic increase method, let's try to solve this. So uh, you can solve it with me. So as discussed, our first step would be to write what is the year and what is the population growth which is happening. So we have. So I'm just writing down this data. You can also write it down. Yeah, it's 60,000 in our first year, and then 1981 it increases to 65,000. Then in 1991 it increases to 82,000, and then in 2001 it increases to 1,05,132,000. Right. So this is the information which is given to us, and the formula. I'll just write it in a new page. So this is a blank page if you're with me. So the formula for arithmetic increase method from it is there in our presentation also. So I'm just writing it here. Presentation, I mean the video lectures also, it is there. So for this, so this is the formula.
Correct.
Yes. So let's come here. So this is the population that we are interested to find in time t in decades, and this is the initial population that we have, and t here is the decades or the number of decades, like the similar to arithmetic increase method where we say how many decades of increase are we calculating, and mi over here is the rate of increase each year. Our same m which we saw before. So here mi we are denoting it as. So this is the rate of increase each year. And now we see there's an additional term here, k, which is actually the rate of change in increase. That means it's not just the rate of increase, not just the rate of increase that we are considering, but the rate of change which is happening in the increase also we would be using. So here we have to find two elements, like that is the first one, what is the rate of increase and what is the rate of change of increase. These both we have to tabulate from the information which is given to us. So from here, let's take the first one, which is increase. In order to find the rate of increase, let's take increase. So yeah, so like what we did, we would be subtracting this both, subtracting this both. Yeah, so let's do that quickly and come up with the answers. First one, yeah, this is very simple calculation. And we'll just total it here itself. So now once this is done, we also need to find what is the incremental increase, because we want to find K also. Sorry, this is the incremental increase. So that whatever is changing, so that we will take this both value, and this both value. Right. So first one is again, yeah, so this calculation is a bit easier. I'm just totaling it also over here. Right. So everybody with me till here, these calculations?
Yes, ma'am.
Okay. So yeah. So now in the first one, that is in increase, we are considering four, like one, two, three, four, like for 4 decades we have. The incremental increase for the first 2 decades, it will not be there because we don't have an increment happening there. So we have this only for three decades is the incremental increase. So when we are averaging, in order to get MI, we would be taking 72,000. We would divide it by 4, but the incremental increase, we would be dividing it by 3. So let's do this, and yeah, if somebody can quickly do this and tell me what is M value, that is 72,000 divided by 4, and what is the K value, which is 22,000 divided by 3.
Ma'am, first one is 18,000.
Very good. And the second one?
27, yeah, just a minute, ma'am. 7333.3.
Right. Very good. Very good. So we have got these two values. So now once we have these two values, then this calculation becomes very simple. So in this particular case, again, we've been asked to find, so one thing which we missed from the question was we've been asked to find for 2031. And the information so we have from yeah, so we have from 1971 over here. So for 2000, yeah, 2031 is what we are interested to find. So which means we have, sorry, I'm going to a different slide. Yeah. So which means we have 6 years of like progression that we need to find. So that also we have, that is what is our T, which will be 6 years. So let's plug all of that over here. So our P 2031 would be equal to our best population. 60,000 is what we are taking. That is 1971, 60,000. So 60,000 plus 6, that is our T, into our 1,800, which we, sorry, yeah, 18,000, sorry, 18,000 plus again 6. So this is T. So 6 into 6 plus 1 divided by 2 into this value, whatever we got, 7333.33. Right. So this calculation, I think you all can do and tell me the final answer. Parallelly, I will also do here. Yeah. If anybody has got the answer, you can just cross check the answer and let me know. Or if you're getting a different answer also, you can let me know.
Ma'am,
Ma'am,
Yes.
shall we round it up?
Yeah, you have to. So in the
ma'am, can you
question,
explain some
So in that
values?
case, the answer is correct, ma'am.
yeah, so in the question it's asked round off to the closest integer. Yeah, somebody was asking a doubt. I'm sorry I missed it.
Can you please explain the calculation part?
Yeah, you want explanation for the calculation. Okay, so you want in this formula how we put it? Is this the portion that you're asking?
Yes, ma'am.
Okay, so let's just go back to this is our formula. So Jairaj, the formula is clear to you, right?
Yes, ma'am.
Right. So in the formula, we need to find what is like we need to plug in these values. That is P0. So P0 is the initial population that yeah. P0 is the initial population that we are considering. So from the question, we know that we are taking 1971 as our initial the data based on the data that we have. So that is 60,000. So we put 60,000 over here. So that's what we have put. Then we need to find T, that is the decades or the number of how many decades after which we want to see what the population is. That is here it's 1971, and we want to see what will be the population in 2031, which means after not 6 years, sorry, after 6 decades, how much the population is going to increase is what we want to find out. So that is our T. So that is what we wrote over here. That is our T is equal to 6. So we are putting T6 over here. Then we have MI. MI is the rate in increase. So that is what we calculated over here, MI. How did we calculate MI? By taking the difference between, sorry, yeah, how did we calculate MI? I'm in slide number 9 explaining the calculation of MI, where we take what is the difference in the population each year or in each decade, how much is the population that is changing. And after we take that, we
Okay.
average that
Ma'am,
out.
ma'am,
Yeah.
ma'am, can you explain the from how to take out the value for K?
Okay, so this part you're clear. Increase part you're clear. How to take out the value
Yes,
for
ma'am.
K.
Yes,
So
ma'am.
K is basically the change which is happening in this increase. So after we get the increase, we want to see how much that increase is varying. So just to go back to our previous simple example, that is from A to B, if it is changing, like there are 100 people, and from B to C, if there is only 50 people who are changing, that means there's a reduction of 50 people. That is, the change which is happening is less. That is 50, it is decreasing. So similarly, we want to see how much that change is varying over here. That is in this in the increase. So we observe that first in the first time the increase is about 5,000. In the next time it is about 17,000, which means it's increasing. The increase is not constant. Then it's again increasing to 23,000. So we want to see what is that. Sorry, yeah, what is it different? So that is what we're doing over here. So we're calculating this by taking
Yes, ma'am. So the
17,000
total was
minus
seventy-two
5.
thousand.
Huh?
The calculation was the 72,000.
The 72,000 you're asking?
No, ma'am.
Huh?
The total increase.
Yeah, total increase is 72,000 for all the years that we have considered. That is
Yes,
for
ma'am.
after 4 decades, it's just 72,000 population is increased. Was that your doubt?
No, ma'am. Wait.
Okay. Okay, so yeah, so just to continue, we're taking that incremental increase, that is K, and we're plugging in onto the formula. So once we plug in onto the formula, then this is basic calculation simplification. So Jairaj, I hope it's clear right now.
Yes, ma'am. Yes, ma'am.
Right. Uh, any more doubts, or we'll proceed on to the next question. Yeah, just to come back here, which is the option which is right? We just calculated it. Which option is right? Okay. Option C is the right answer. I think most of you got the calculation, so uh, we can proceed further, right?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, good. So now those were two calculations which we saw, arithmetic increase method and incremental increase method. So now let's look into some more theory questions, and then after that uh, we would do one more calculation in the end. So this question is regarding the design period of different what is design period. So it basically asks which of the following questions are correct. So we need to mark the correct questions regarding design period. So let's revisit on what a design, before we can look into the questions and brainstorm whether it's right. The options are given in a bit confusing way. So before we do that, let's look into what a design period is and how it's relevant, and what are the different factors that influence the design period. So firstly, design period is in fact the first thing that is considered while designing. So while giving an introduction to arithmetic increase method, I said we design the utility for a certain period. That is, we forecast for a certain period and we ensure that the utility would be served for that much period. And that is the design period. So usually about a 30, average for 30 years is what we design any utility like water supply, sanitation utilities. 30 years is the average period that is used. But again, there are certain factors or reasons by which this can be either increased or decreased. So, and yeah, so this design period is usually calculated after the completion of the, sorry, yeah, after the completion of the project. So if the project takes about 5 years to build, then the design period and the design period is 30 years. That means for the next 35 years, if you're starting the project right now, for the next 35 years, it would be there in intact position. But there are some, as I discussed, there are some factors, and to start with, the life cycle of each component in that design period, in that utility that we're building, they also define the overall design period. That is, there might be, like, imagine we're building for 30 years, but there might be certain components which will not sustain for 30 years. For instance, the pump or the motor or something small that we're using, it might have a very less, like probably 10 years or 5 years might be the design period for that. So for each component also we look into the design period. And we mentioned that these needs to be replaced for maintaining this for these many particular years. But when we say that the design period is 30 years, it means that the overall facility or the utility that we're giving, on an average, it will sustain for those many years. And also, we increase or decrease the design period based on other opportunities which we have, in which the service or the utility is going to be put in. For instance, if there is an opportunity for expansion, then we would design, if there's an opportunity, then we can design it for a shorter design period, because incrementally or with time we can expand it. But if there's no opportunity of expansion, then we need to design, the design period should be increased so that whatever we are providing caters to a longer duration. That is, it will, because we cannot expand further, so it has to cater to the maximum how much it can. And also the different finances which are available. That is, if you're running low on finance, then that means we cannot invest in long lasting equipment and other services. So if you're low on finance, then obviously the design period will also reduce. Similarly, the rate of interest, that is, most of these projects are done on loans. So if the rate of interest is high, then we do not want to invest a lot on it. And then if there's an opportunity of future expansion possible, then we can easily reduce the design period, so that with the amount that we are loaning right now, we can build the facility and later we can keep improving it. Similar to this is the availability of land for future expansion. That is again the expansion opportunity which is there. So if the land available is less, then that means the design the design period should actually be increased so that we can it's maximum. And the population and land use growth. So this is again this is a very important factor over here, because if the population and land use growth is increasing rapidly, then what do we do? That means it's keeping on changing fast. So would the design period be increased, or would the design period be decreased? So I'm just putting it on to you. Like, what do you think it is? There's a rapid increase in population growth. Yeah.
If the population is rapidly increasing, then I guess the design period will take more time.
Okay, so you're saying if the population is increasing rapidly, then the design period will be longer, is it?
Yes, ma'am.
So, which means on an average, if it is 30 years, which is being served, like the utility is being served, because the population is rapidly increasing, you're saying that it should be designed for about like 50 years. Am I right? Yeah, that's an interesting observation which you have made. Any other observations? Does anybody feel that this opinion is right, or do you have a difference in opinion?
Just a minute, ma'am. I have one doubt.
Yeah, sure.
Ma'am, what is the definition of design period? Is it the time taken for constructing, or it is the time taken for construction as well as consuming and then the expiry as well?
No, so in design period, the construction does not come into play. Design period is basically the duration for which the utility will sustain, or the utility will serve the people. That is, till how many years can it be used? So the construction time, or I think the term design period is what is confused. It is not the time taken to design, like no, this is not the time taken to design. It's basically the time period for which it will sustain, or it can be used by the user. So we are talking about the utility. So that water supply facility will be available for the users for these many years. So as I said, 30 years. So when we start building, so if you're starting to build right now, it basically says at no, basically if you're completed right now, for the next 30 years it should sustain. That is what a design period is. And
Ma'am,
whatever
then
you're talking about, the construction period, that also, like if it takes 5 years to construct, then it's added to the design period to say that about for the next 35 years it will stay, because 5 years it will take to be constructed. And then from then, after it's completed, again a 30 years it should sustain.
so ma'am, in that case, if the population is increasing, then I think the design period should be less.
Okay, so you're changed. So now you're saying it should, if it is 30, then it should be like 20 years, right? That's
Yes,
what you're
ma'am.
saying. Right. Very good. Anybody, any other opinions? Okay, so let's see whether this. So that was a very interesting discussion that we had, and how you arrived at it should reduce. So let's just discuss that in detail. So I would say you're right. So what happens is that, imagine we have so we learned about how population is increasing. So there are I'm taking very simple cases. So there are about 10 people, and slowly it's increasing to 20 people, 30 people. Eventually, like it's increasing to 60 people. And let's say that the capacity of the utility, that is A, or the capacity of the utility, which is A, is to serve 60 people. So when the rate of increase in population is low, it takes a longer time. Like if this is steep, it takes a longer time to reach this capacity A. So it's a very gradual increase which is happening. And on the other side, if the population increase is rapid, that it is going very fast, then this A, like it is 30, and then in the next year itself it's reaching 60. So T dash over here, imagine in T dash we are reaching A. So which means our T dash is actually lesser than T. That means within a very short time, it is reaching the capacity. So as discussed, our design period is the time period for which the facility should last. So if we are keeping it for it to last for 30 years, or yeah, if you're keeping it to last for 30 years, and if our if our T is equal to 30, then yeah, so this case it's good. But over here again, we are keeping it for 30 years, but T dash is less than T. which means less than 30 years, like within less than 30 years, the facility would actually reach its full capacity. So this means that our design period will actually needs to be reduced if the population increase is very rapid. So which shows that whatever we are designing, so if the population is completely changing, then we need our design period should be reduced so that with change in population we can expand it, or we can look at the trend which is happening and expand it, or else the capacity, that also matters. Similarly, the same thing would happen in land use growth. That is, if you have a land use growth, if you have a land use growth and you design, you keep your facility based on the existing land use growth, and if the change is very gradual, then this facility, the location of the facility will also be adequate enough in order to cater to this. But if there's a rapid change which is happening, which means like in one corner there's an industry which has come up and suddenly there's a lot of utilities which are required to this industry, then this positioning might not be adequate enough to cater to this. Like positioning something very close to the industry, a utility very close to the industry might be more useful. So which means we would have to build another facility over here, which again means that if you're designing for a longer duration over here, that will become obsolete, and it cannot, the full potential of that cannot be used. So in this regard also, when the land use is rapidly changing and when the land use growth, there's rapid growth in land use also, we need to reduce our design period so that maximum benefit can be achieved out of it. Right? So yeah, so you were right. If the population growth is very rapid, if the land use growth is very rapid, then we would decrease the design period. Right. So any doubts, or we can proceed on to the next question?
Ma'am,
Hmm.
so population growth and land use are directly proportional, right?
Yes, there is a relationship between population growth and land use, but I wouldn't say it's directly proportional in a linear way, or because there's a relationship. When land use is sorry when land use is growing, that is, there can be different types of land use, right? So there can be, which I think my slide did not change. So in this slide, so when the land use is changing, so here we are talking about growth in land use. So it can be the industrial area is growing, the residential area is growing, or probably you have, so there are different kind of land use which is happening. And whenever there is an increase in land use growth, yes, a population growth is also what it accompanies that. For instance, the residential area is growing, that is again, so if the residential area is growing, that is again linked with the growth in industry or employment opportunities. So these are planning level details, or certain planning theories are there which talks about what attracts people, like basically what is the push factor and what is the pull factor which leads to the increase in population in a region. So yes, so these are interrelated, but the actual relationship, if you say that they are directly proportional, that requires, like, in order to confirm that, that requires more detailed exploration. Like, it depends on the context also. But yeah, there is an interrelationship between population growth and land use growth.
Okay, ma'am.
Right. Okay, so let's proceed on to the next question. So this is again very in when we were discussing about different mathematical models, we've already discussed this in brief, but we will discuss about these models in detail in this question. So the question asks, which of the following statements are incorrect? So we need to mark out which is wrong. So the first one, so basically, if you look, it mainly talks about mathematical models. So all the questions are about mathematical models for predicting population growth. So before we look into the different options, let's look into more detail on what are the different population forecast methods. So we already saw how we can solve using arithmetic increase method and incremental increase method. So apart from these, there are several other mathematical methods also. And there are certain criteria that we need to follow in order to use these mathematical methods. So what mathematical methods basically does is that it looks at the growth which is happening, or the past growth, and then it projects what will be the future growth. So this is one method. Or the other method is that it looks at the growth which is happening in a similar location, and then it projects what will be the growth in our particular location. So these are the two methods which are used in mathematical models. And as you know, it's completely mathematical. So whatever variations or some uncertainties or all those deviations which are happening, these mathematical models will not be able to cater to that. So there are two assumptions like which are made. One is that the growth is regular, or the pattern in which past growth was happening, the same way the future growth will also happen, or the same factors which influence the growth in another location, the same factors are influencing the growth in our location. So the pattern or the rate, whatever is happening, will be the same. So it's basically the growth will be regular. There's no sudden undulations which are happening. So for instance, if there's a new industry which is, so in the past there was no industry, and suddenly in the future there was a new industry which is coming, then our mathematical models cannot be used because the growth pattern or the whole growth rate would vary. And yeah, so similarly, there's no other major societal or economic changes which are happening. And another factor is that we do not look into what are the different age groups and how the gender is also changing. So we don't separate them. We take population as a whole and then say that, okay, there were 100 people before, and after 10 years, it became 150. So 10 years from now, again, a 50 more people will increase. So it's a very basic mathematical approach. We've already done the calculation, so you know, we do not differentiate between age groups and gender. And yeah, so we discussed this both, and geometrical increase method is also very similar. It's again used in cases where there is an exponential growth. For instance, if there is an industry which is coming, then in that case, the beginning when the industry has come up, there'll be sudden increase. So that is the time when we use a geometrical increase method. And after certain years, like 10 or 20 years, when we feel that the effect of the industry is going to reduce, we stop the geometrical increase method because as discussed, it cannot cater to the irregularities. So whatever increase that we are postulating should happen throughout. So that's geometrical increase method. Then yeah, then there are other logistic increase methods and graphical methods also. Now, for the other methods, or so because of these reasons, mathematical methods are not usually preferred for population forecasting because, as discussed, there are so many assumptions and it might not give the actual prediction. So there are the other methods, such as economic methods, are most suitable. And again, in this, there are different methods, such as the employment ratio method. So it basically looks at how many, like, what is the attraction rates, like how many people are employed and what attracts people. And then we also have the ratio method, where we look at what is the ratio of growth which is happening. That is between 2 decades, how much ratio has changed. So again, this takes into consideration the changes which are happening in the area, region, urban area that we are considering also. And the most important methods are this. Uh, sorry, yeah. The most important methods are this migration and natural increase method and the cohort survival method. And this cohort survival method is the most reliable and most commonly used method. So just a brief outline for this migration and natural increase method. We look at the total number of births which are happening, the deaths which are happening, the immigration which are happening, and the out migration which are happening. So we look at how many people are coming and going, but again, it does not differentiate between different age groups. So the cohort survival method, it actually differentiate between age groups, gender, and we get a clear understanding on the population split also. That is how many people, how many for what age group it will be there. So this is the most commonly used. So let's come back to the question. Here the question was that mathematical methods are suitable when population growth is sorry, yeah, mathematical methods are most suitable when the population growth is irregular. Yeah, I think we've already discussed. So you can tell me whether the first one is correct or incorrect. Is it suitable when the population growth is regular?
Yes, ma'am.
Okay, so this means this is correct. Fine. And what is this second one? It does not consider any social or economical changes. Is this correct?
Yes, ma'am. No major society. Yes, ma'am.
Yes, this is also right. Now, mathematical models consider different population, age groups, and gender. Is this right?
No, ma'am.
Okay, so this is not right. It does not. And the last one, it predict population using population growth rate from the past period. Right. So that is also right. We just discussed that. So I guess so here we have to mark what is incorrect. So C is incorrect. Right. So, okay, so now we have only 5 more minutes, and
Ma'am,
yeah,
I have one doubt.
yeah, sure.
Suppose a country has got recently hit with any inflation or recession, say,
Yeah.
so there is an economic change. So in that case, will a population forecasting be a problem or possible? We can do
Yeah,
it.
that's a very, very interesting questions. Very interesting question that you asked. Yes, the thing is, whatever happens, we will have to, when we're designing something, not just the utility, when we're doing a land use planning or any planning, we will have to predict the population growth which is happening. So, as discussed, these certain external factors which contribute, which changes the population growth, these factors, it'll be very difficult to capture them. So that is why we have all these models like mathematical models, economic models. The aim is to use these models and capture the changes which are happening in this region. So as you said, if there's inflation or if there is some major economic change or societal changes which is happening, then we have to go for economic methods, because mathematical methods will not be able to capture this change. So that is where all these economic, like, so in this case there's an inflation, so that might be reflected in the employment ratio. Because of inflation, the employment ratio might have changed, or the ratio of growth, the ratio method which captures the ratio of growth which is happening in the previous, so we can capture the inflation which is happening, that the ratio in the past 2 decades, or the past like 4 decades before, the ratio of change might be very less compared to the ratio of change which happened in the last decade, like just in 1 decade. So we see that inflation or that sudden spike which is happening. So based on that, so the choice of method that we use also depends upon the context or the behavioral changes which is happening. So that is where usually what we do is we try to analyze, or we plot and we see how much change is happening, or we visualize what change is happening. And based on this change, now for a future production projection, we try to take this data and we try to make a curve, or we try to use a function by which we can predict, we can capture this whole change which is happening. So as discussed, our migration method or cohort survival method, so it's mainly an trial and error method where you try to minimize the error which is happening. So I would say it's with respect to time, sorry, with respect to the context only, you would be able to say which is the appropriate method to be chosen. So yeah, so these certain uncertainties we will have to consider, and if we ignore them, then we will not be able to get the appropriate projection. Our projection will be flawed.
Okay, ma'am. Understood.
Right. So I think we have come to the end of this session. So if you have any doubts regarding the overall session, you can shoot.
Yes, ma'am. Also, one thing you taught us like the incremental, the geometric, arithmetic. So, in that case, when we are using any data, is there any specific method to follow? Like this data has been given and we have to do arithmetic or geometric. Like how we will be
Huh.
like defining them?
Right, right. Yeah, that is a very, again, a very interesting question. How to even in, so as discussed, if there's an economic change which is happening, you know that you need to go for economic or societal changes. You know that you cannot use mathematical models. That is clear to you. But within the mathematical models itself, how do we choose which mathematical model to use? That is your doubt, right?
Yes, ma'am.
Yeah, right. So, if I'll just tell you which slide number also. When we in the lecture series, when we discussed about population forecast, there was one slide where we have. So I'll just I'll just draw it here. Yeah. So if we have if it's visible, so if we have a year, and we have the population increase which is happening, so as it goes up, the population is increasing. So if it's a very slow increase which is happening, that is over the years, the overall increase which is happening is very less. So that's why I said we visualize the data first. We look at how the rate of increase is happening. So if it's a very slow increase which is happening, we always go for arithmetic increase method. Because why? Because that means the rate of change, that is the slope, the change in slope which is happening, that is very less, like there's not much change, which means an arithmetic increase method is suitable for this. But whereas if there is a sudden increase or sudden spike, something like this, which means exponentially the population in that region is growing. So as discussed, maybe a new industry came up, or maybe a new residential settlement came up, new job opportunities have happened. So something might be there. So exponentially it is increasing, and probably after a point, then maybe the increase might be reduced. So for this point where suddenly there is a spike in increase, we go for our geometric increase method. So by looking at the curve of increase which is happening over all these years, so for the past 10 years, if this is what is happening, we can imagine and we also look at how long has this happened. So as discussed, there are two methods: past whatever is happening, and in a similar region how it has happened. So in both cases, past also it's exponentially increasing, and in a similar region also, after like even after 10 decades of this increase, probably for another 10 decades also it is going to increase like this if we have. So that is again a domain based knowledge. So the planners would use their domain based knowledge to say that okay, next 10 years also it will grow exponentially because there are certain factors which leads to that. So then we use a geometric increase method. Now if this is not the case, and if it is, the increase is more or less gradual like this, like it's not too low or it's not too fast, then we go for an incremental increase method, because there is an increment in increase which is happening every year, and it is not either too slow or either too fast, or it is not too slow. So we go for an incremental increase method. So this is the basic for mathematical models. This is what is used. But again, when there are other economic factors which are happening based, so we first do a survey on that. What are the different factors? What is the attractions which is there in red region? So based on this, again, we choose the other economic based methods. Right?
Yes, ma'am, clear.
Okay. So before we conclude, we discussed two methods. So I thought we can do one question on geometric progression. So this is not part of your assignment. Like geometric progression is not asked in your assignment as of now, but for your examination point of view, I put this question. So you can try solving this question yourself, because formula, everything is there. Or do you want me to discuss this question right now? Okay, probably I'll just give you out the method. The calculation part, you can do it yourself and do, because it's a bit different from the arithmetical and incremental increase method. So we'll just quickly go through the method to do this, and we will wind up for today. Please share the method. Yeah, I am sharing the method right now. Okay, so to begin with, again, I'm not going to do all the steps. I'll just tell you. So this will be the year. We will write down every year how do we go about it, and then we will go about how much population, like growth. So basically, I'm transposing it and then writing. So in our geometric increase method, the formula that we are using is that, I'm just writing down the formula over here. Right. So this, we know that it is the time period for which we want to predict, and this is the initial population. And M, we know that is so here M is our geometric mean, or how much geometric mean. Previously it was the arithmetic mean which we took. Even in incremental increase method we took the arithmetic mean. So here we will be taking the geometric mean, and T is same like before. It is the years, the decades, the number of decades after which we want to calculate. So yeah, so here in the next table, we will write what is the increase which is happening. So we will again subtract. So just the two values I will write. So first year it is 855, and the year after that it is 72. So I'm taking the difference to get the increase, which will be right. So once I get this difference, now in arithmetic increase, this was enough. Like we just needed this. But here, what we're interested to find is a geometrical increase. So after we subtract, we also have to divide it by the base. So our geometric increase value would be this divided by our initial value, which is this 85845. Right. So we get this ratio like after we divide. Now what we need to sum, what we need over here is, sorry, yeah. What we need over, oh, sorry. I'm sorry for the technical issue. Yeah, so what we need here is all these values, like for every pair of decades, what is the ratio which is happening or the geometrical increase which is happening. And once we get this, we know the formula to find the mean, like geometric mean. The formula is that nth root of pi I raised to 1 xi, which means in arithmetic we added everything and we subtracted, and we took the average. Here we would be multiplying everything. So for all these years, we would multiply all those values. So over here, for all the years, we would be multiplying it, and then we will divide it by. So here, how many years data do we have? So we have like, so this will be our 1, 2, 3, from here, this to this. Yeah, so this will be 4 and this will be 5. So basically 5 years data we have. So this will be raised to 1 by 5. This is how we find the geometric mean. And once you get the geometric mean, then you can just easily plug it onto this formula over here and you will get the answer. So yeah, so this you can try it out, and in case you're facing any difficulties, you can put it in the discussion forum, or next week when we have this discussion, you can bring it up. We can discuss that next Tuesday.
Okay, ma'am.
Okay, so I hope you all had a wonderful time, and hope you can complete the assignments right now. And we will see you all next week. We will mainly be discussing about week twos, and if time permits, we will take this also. So yeah, so have a good evening. See you all. Bye.
Thank you, ma'am.